Hello everyone. Am I audible to all of you? Can you all answer me? Am I audible to all of you? Okay, so sorry, there was a glitch from my side. I corrected it. So happy Independence Day, and it's a very proud moment for all of us. Secondly, I wanted to ask something from you. What would you suggest that we should keep this webinar in English itself, or should we shift to Hindi or English? Whatever you like. Would you like me to speak in English itself, or do you prefer Hindi? So please, can you tell me this thing in the comments? So I will I'll do the workshop according to that. Okay, so let us see some comments here. Okay, some are saying English. Okay, so most of the students are saying that we should keep the webinar in English itself. Okay, no problem. So we'll keep the webinar in English itself, and if someone found something difficult to understand in English, they can tell me. I'll tell all of it in Hindi also. Okay. So, okay, many students here are saying Happy Independence Day. Yeah, so I already wished it, and yeah, that is a very proud moment for us. And I hope you must have already are done your kite. You are done with your kite flying things, right? You must be flying your kites from morning or afternoon. I don't know, but I do. I also did fly some kites. Okay, like I'm not so perfect at it at kite flying, but yeah, I did it. Okay. So moving on. First let me first tell you the agenda for the workshop. So the agenda for the workshop would be would be something like that. First, we'll see what is bit masking. We'll be seeing certain bit masking techniques, because there are many students like those who have some problems in bit masking, like they don't even know what bit masking is, right? Okay, so camera is okay. I let me check it out. Actually my video is clear, I guess, from my side. It's okay, I guess. Okay. So the agenda would be something like that. First, we'll be talking about certain bit masking operations, that how bit masking thing works and why are we doing bit masking, how it is helpful in competitive programming, and then we'll shift to certain oven approaches which helps us solve questions pretty much faster. After that, we'll switch on to that how we can solve questions by the help of bit masking. We'll see certain questions which you can solve by the help of bit masking, right? So let's start with the workshop itself, and I hope you will all enjoy it, right? So let me share my screen here, so you all will be able to see it. Okay. Okay, here, let me see the comments. Okay, here, let me see the comments. Okay, so am I screen clear now? Are you all able to see me? I guess some students are having some issues here. Some students are facing small issues that the screen is not clear, but I guess now it is clear to you. Okay, Lavish, the question for Lavish is that, sir, will you teach in Java or C++? So I'm a Java programmer, and I'll prefer Java itself. Okay, but doesn't matter. Algorithms are just the same everywhere, even in C++, in Java. But there are certain new things in Java also, which I'll tell you that what are the new things that are not present in C++ but they are present in Java. And yeah, we'll be doing the coding stuff in the Java programming language itself. Okay, so those who have this small doubt that can we do competitive programming in Java or not, so yeah, I am here. I'm teaching you in Java itself. So yeah, I do my competitive programming in Java itself. And doesn't matter which language you choose, you can do competitive programming in Python, you can do it in JavaScript, you can do it in any language you want. You can even code in JavaScript, right? So let's start with our workshop. So the first question that comes in our mind is, okay, so Girish already asked that question. So what is bit masking? Okay, so the first question is that what is bit masking? So if you take a closer look at this name, okay, bit masking. So as you can see, there must be something related to bits, like bits this. Okay, like even when you first see computers and your teachers tell you, yeah, this is a computer, this works, or this stores data in the form of bits, this binary form, this and that. So we all know that the data is certainly stored, like the numbers are stored in the binary form in your computer. And yeah, this binary data is very close to your computer's heart, right? Like it is the machine language, and the machine understands it pretty well compared to the arithmetic operators that we generally use. So yeah, bit masking will be generally dealing with bits, and we have two bits only. And I guess you all know what are the bits we have. So write down in the comments that what are bits. You all know about bits, right? 0 1. There is nothing else. Bits 0 1. That's the only thing that comes in our mind. Okay. So bit masking will be manipulating our bits, or bit masking, you can say that it is a form of bit manipulation. In this, we'll be like manipulating our bits in such a way that we can get our desired results, the result that you want. We will not be using those arithmetic operators like your modulo operator. There are certain operators, like for odd even approaches, you use modulo by 2. Okay, if it gives me 0, then yeah, it is divisible by 2. If not give 0 by 2, then yeah, it is an odd number. So yeah, there are many things like that, but we will not use them. Okay, because in interviews they won't ask you a straightforward question like that, ki, come on man, tell me that how I can check whether a number is odd or even. And you say, okay, I'll modulo it by 2. If the remainder is 0, then it is an even number. If the remainder is not 0, then it is an odd number. And like it is not that easy. Okay, so yeah, today in this lecture we will go through all of these things. Like if someone tells you that you don't have to use modulo operator, then what you can do. So we'll go through all of that. So I hope this term meaning is clear to you, bit masking. In this, we'll be creating certain, like we'll be working on bits, we'll be creating certain masks to retrieve our answers, to get our answer. Okay. We'll be manipulating our bits mainly. Okay. So if someone asks you what bit masking is, so basically you can say that in this we are generally manipulating our bits. You can also say bit manipulation. In bit masking, we generally manipulate our bits and try to get our desired result. Okay. Now, okay, so there was some one question, sir, which language is better for competitive? See, all languages are better for competitive. There is no restriction on that. But the thing is that there is a certain standard that if you are doing competitive in Java and C++, then it's fine, because these are the fundamental languages. So if you ask me that in which programming language should I do competitive programming, so I'll basically be telling you that either go for Java or C++. You can go for Python also, but I'm not like, there are some companies that doesn't allow like competitive programming in Python, so that's why I avoid it a bit. But yeah, if you want to do it, you can do it. I'm not saying that you can't really do it at all. Okay, so it's totally your wish. Go with any language that you want and just understand the things, right? That's the main idea, I guess. Okay, so let me share my screen here. Okay, share. Okay, so I hope you are able to see my screen. Like, are you all able to see my screen here? Can you tell me in the comments that are you able to see my screen? Uh, are you all able to see my screen here? So we'll proceed with the concepts. Okay, so everyone is able to see it. Let us start with the concepts then. Bit masking, I have already told you. It's basically you can say some student wrote this manipulation of like playing with bits. Yeah, that's a good thing. Playing with bits. Okay, I'll write it here. Playing with bits, or giving a standard definition, you can say manipulating your bits, which you also say as bit manipulation. So basically, in this bit masking, we'll be manipulating our bits by the help of certain bitwise operators that we have to retrieve or achieve our desired result. Okay, so you can say bit manipulation here. So okay, now moving forward, the second thing is that bit masking approaches are faster, and some people might think why. So the thing is that bit masking approaches are faster. That is because you all know that computers generally works with bits. Like if you say 5, how is 5 stored in a computer? Like, can you tell me that how 5 is stored in a computer? What do you think? How it is stored? Do you all know how a number is stored in a computer? Can you tell me in the comments how a number is stored in a computer? I guess everyone knows the answer. So a number is basically stored in binary form, right? If I ask you 5, so what is the binary for 5? So the binary for 5 is 101. Okay, and yeah, writing the binary for a number is very easy if you ask me. What you need to do is just think something like this. Suppose you have something like let me write it here. Suppose you need to create 5. So what you will do is, first of all, you will write here. Suppose the first thing is 2 raised to the power 0. You will see that whether you need it or not. So I am dealing with an odd number. So yeah, I do need a 1 here. So I'll say that yes, I need a 1. Then you will say 2 raised to the power 1. This gives you 2. And 2 raised to the power 2 gives you 4. So out of these three, which one do I want? So out of these three, which ones do you want to form this 5 here? So yes, the answer is pretty simple, that I want this 4 and I need this 1. I don't need this 2. So I got 101, and this is how I was able to form the binary for 5. And this is a very simple approach, and I guess everyone can remember this. Okay, you don't have to be like that. I'll create a table, I'll keep on dividing 5 by 2, this. No need to do that. You just have to think like this: 2 raised to the power 0 is 1, 2 raised to the power 1 is this. Like, you can keep on writing 2 raised to the power till you get your results, and you just need to set 1 there, 1 at the place which number you want. So for example, for creating 5, we needed 4 and a 1, but we didn't need it 2. So I set it 0 here, and I set it 1 and 1 here. So 101, I got the binary here. So is this clear to you, everyone? Is this clear to you, everyone? Is this clear to you? Like, will you remember this small hack for getting the binary for any number? I guess everyone has got this approach. So then we'll proceed to the next part. Okay, everyone, is this clear to you? Can we move forward? I'm waiting for your comments here. Okay, everyone is saying yes sir, yes sir, yes sir. Okay, it's clear to you. Now let's move on. Okay, so OneNote is giving some problems here, I guess. Okay, no problem. So here, now the thing comes that suppose you have a negative number, suppose you have -5, then how will this -5 get stored? Can you tell me? Like, now I am dealing with negative numbers. Can you tell me how a negative number is stored in the memory? Is it stored in the same way? I don't think so that it can be stored in the same way. So some students will be writing in the comments, like, I already know that what you will write. You'll say, yes, a negative number is stored in the form of what? Sign bit? Yeah, okay. Nothing like that. A negative number is stored in the computer in the form of 2's complement. So, okay. Now the second question that I am going to ask you is that why 2's complement? Why can't I store it simply like this or something like that? Like, why do I need 2's complement? So the simple answer to this, that why do we need this two's complement, is because computer, we all know that computer is a fool. Everyone, when you were studying, like when you were kids, everyone tried to say you that a computer is a fool. He can't do anything without you. You are the source for his, like, without you, a computer is nothing. Like, this is a very funny thing which everyone says, that without a person, a computer is nothing. And we also know that without us, that computer would be nothing. So yeah, we do have a job, even though we don't. Okay. Right. So now the thing is that we know that computer is a fool, and yeah, computer is a fool. He don't know how to subtract. What he do know is that he knows that how to add two numbers. So what he says is that if I have this 5, so now for this minus 5, he don't want to add any more circuits or any other more logics. So what he simply says is that I should have a form by the help of which I can simply add the two. Like, it will not take, if you write something like 5 plus, like 5 and minus 5, then now you are trying to subtract two things, 5 minus 5. Now the thing is, what you all will be thinking is that yeah, computer will say 5 minus 5 0. So no, computer doesn't know how to subtract. What he will do is he will say, okay, I'll keep the two's complement form of 5, which will give me minus 5. So it gave you a form to store the negative numbers. And now what it will do is it will simply say you, okay, you don't have this 5 minus 5. He will break this down into 5 plus minus 5. So this makes it easier for him, because now if you can say here is a two's complement form, here is a normal complement form, and now when we add these, so we all know that a computer knows how to add. He don't know how to subtract, but he knew how to add these. And if you add them, you will get a zero itself, and that's a done deal. Okay, it's sure. Okay, so this is how a computer works. So a computer stores thing in the form of binary data, and if you ask about a positive number is stored in the form, in the normal binary form, and a negative number is stored in the two's complement form, because your computer doesn't know how to subtract things. So what he does is that he needs to keep the logic same, that the adding logic, he know how to add two numbers. So what he did was he got a two's complement form for the negative numbers, and this is how things worked. Okay, so I hope this much is clear to you. And now what we will do is we will start with the bit masking operators. Okay, we won't like go too much into the depth of these theories, because what we need to do is we need to know competitive programming, right? I guess most of you might be from like most of you might have done some data structures already, because if you are here learning about competitive programming, so yeah, a basic knowledge of data structure is very important, and I guess all of you have that. So now we will start with the bit masking operators. But before that, what I want to tell you all is that bit masking is a very important approach. If you have not given any interview, so let me give you a small hint that when I gave the interview for Amazon, like I have cleared the tests for Amazon itself. So in Amazon, they generally ask you question upon bits itself. So there could be like count the set bits in a number, or there could be something like magic number, unique number. There are many questions, and Amazon generally asks bit masking question. So I hope like after this session, you all will be able to start solving these bit masking questions. You don't have to go into the depth of these theories, that how a computer works, how bits are working inside the computer. It was just a normal knowledge that I wanted to give you. But now the main part in bit masking is solving itself. Okay, the main thing in bit masking is solving the question. Okay, so let us start solving the question, and just tell me that the things that we have done yet, are they all clear to you? The questions that we did right now, are those clear to you? Like the things we did right now, is that clear to you now? two's complement form. Some students might don't know that how to calculate the two's complement form. So if you want to like get the two's complement for any number, so suppose 5, so what you will do is that you will first write the binary for 5. After that, you will complement all the bits. By complement, I mean that if there is 1, we will change it to 0. If there is 0, I'll change it to 1. And if there is 1, I'll change it to 0. And after doing this, what I will do is I'll add a 1 to it. I'll add a 1 to it. Okay. So now adding 1 to it, what do you get? This. Okay. So this is how 2's complement is calculated. First, you will write the binary. After writing the binary, you will complement all the bits. And after complementing all the bits, you will just add 1. Okay. So this is how 2's complement is done. Okay. So I hope this is clear to you, clear to everyone. Okay. And let us proceed further now. So is this clear to you? Like, I hope most of the students knows the two's, like now you understood that how we can calculate two's complement form. Sneha, I okay, got it. Okay, BJ, I okay, got it. Right. So let us proceed now with the bit masking operators. So there are certain bit masking operators that we have here. Okay. So the first bitwise operators. So let me name it first here, bitwise operators. So let us start with the bitwise operators. And the first one is the AND operator. Okay. So generally we have these, like this is just the name. Okay. It is not the symbol. Okay. So this is just a name. We have AND bitwise operator. We have OR bitwise operator. We have NOT bitwise operator, or you can say complement. Then we have XOR bitwise operator. And after this, we have some special types of operators which we know, which we say as shift operators. These are the shift operators, and there are basically two types of shifts: left shift and right shift. Okay, so we have two shift operators, left shift and right shift. So the students who are working with C++, I there is your left shift and right shift, but those who are working in Java, so there is left shift, and in this right shift there are two things. One is signed right shift and one is unsigned right shift. So I'll tell you about both of them, so don't worry about that. Okay, we will talk about all of these, but first let's take the discussion on these ones. Okay, first we will talk about them, then we will talk about all of these. After talking about the operators, we will start seeing some small hacks, and after doing those small hacks, we will start solving questions. And I'm definitely guaranteeing you that you will get the gist of bit masking. You will be able to solve questions after this lecture. This is just a class lecture, just think of it like that. I'm not thinking of this as a workshop. We are just taking things as a normal lecture. Okay. So we know what bit masking is. We know why two's complement was formed. What is one's complement? We know how to calculate two's complement. We know that these are bitwise operators. So now let's start solving the question. Like let's see what they can do. Okay. So let's start with that. Now let me say first operator was AND operator. Okay, so let us suppose the first operator that came to us was AND operator. So AND operator is something like this. If I tell you, it is denoted by this. Okay, single AND. Just remember this. This is a single AND. Don't write it like this. This is a logical AND, right? This is used to check whether both the conditions are true or not, right? It is not this AND. Okay, this is a bitwise operator. Okay, don't compare it with this one. This was to compare that whether both the things are true or not. It is not like that. Okay, so single AND, no double AND. Okay, so this is how AND operator is denoted. And what is the property of AND? So let me tell you it in very normal terms, and I'll also tell you something to remember it. Like some students get confused in and operator or operator, so we'll do something to like keep it in our minds. Okay, so this and operator, what it do is that suppose if you have two bits, suppose there are two bits a and b, and now what you are doing is you are performing and operation between them, a and b. I am performing and operation between a and b. So what happens is that if I have a zero here and if I have a zero here, so the answer that I'll get is an unset bit. Okay, zero. So what AND operator says that if I like any of the two bits is an unset bit, like if any of the two bits is an unset bit, then the answer would be unset. Okay, so what this means is that if here is one unset bit, so here is also a unset bit, answer will be unset. If we have one unset bit here but we have a set bit here, still what I said was that if there is any unset bit in any of the two things here a and b, then the answer would be unset. So if even if I write this, the answer would be unset. If I say 1 and 0, so the same thing applies here also, that if any of the bit is unset, then the answer is unset. But if both the bits are set, then the answer would be a set bit. This is how the AND operator works. So uh, I'll repeat it once again. What AND says is any of the bits, if any of the bits is set, then like instead of set, we can say unset. Sorry. Okay. So if any of the bits is unset, then the answer is unset itself. Okay, so if there was one unset bit here and unset bit here, answer is 0. If there was one unset bit here but a set bit here, but the answer will still be 0, because we have said that if there is any unset bit, then answer is unset. Okay, so this is what is your AND operator. Okay, and if you see this is see, if you want to see this in the binary form, like let us see, suppose you have something like this 101 and 100. So if I say let us perform AND for these, so if we perform AND for these, the answer that we'll get is 1 and 0. Both the bits are what? Here the bit is unset, here the bit is set, but the answer would still be what? Unset. Here also unset. Here it will be a set bit, something like this. So I hope this is clear to you now, the AND operator. So this was your AND operator. If any of the bit is unset, answer is unset itself. Okay. So I hope this much is clear to you. Now let us start with the OR operator. Okay. So we have already seen your AND operator, right? AND operator was pretty much easy, like very easy. What it said was that if any bit is unset, then the answer is unset. And OR operator says that, come on, man, why would you do that? So what OR operators say is that if any bit is set, then the answer is set. Like life is set. Okay. So if any bit is set of them two, then the answer is also is set. So for example, if we have something like this, okay, OR operator is denoted by this, a single pipe. Okay, there are multiple pipes in the other OR operator, but it is not that. There is a single pipe here. Okay, A or B. So if I say that we have 0 and 0, so there is no set bit, so the answer is going to be unset. But if there is any set bit, then the answer is set. If there is any set bit here also, the answer is going to be set. And if we have 1 and 1, the answer is going to be set. So here all the bits were set itself. Okay, so if 0 and 0, answer was unset. If there was one set bit here, answer was set. If there was one set bit here, answer was set. And if there are both the bits set here, answer is set. So Are these operators clear to you? Like, can you tell me, like, are these operators clear to you? Uh, can you write it here that are is the and operator and the or operator clear to you? Okay, so Vikas said yes. I guess the comments are, yeah, clear. Okay. And to remember these things, like there might be times that you might get confused in them. So let me give you a small thing. So if you are dealing with or, so or was working something like this, right? So this is not a proper hack, I would say, but yeah, you can remember things like this. So what or is that, it is basically performing addition here, like 0 plus 0 0, 0 plus 1 I'll get 1, 1 plus 0 I'll get 1, and by 1 plus 1 I'll still get 1. Just remember this one, right? So this is what or operator is, to remember the table for or. Okay, so this is just a, this is not exactly a perfect hack, but yeah, this will help you remember, like help you remembering the things. In the same way, if I ask you for and one, so a and b here. So what and is more or less like multiplication, like 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, and 1 into 1 is 1. Oh great, done. Okay, so these are the things to remember the or and the and operator. So I hope this is clear to you. Like how was the approach? Like this is the simplest thing, I guess, right? Okay, now, okay, now what we will do is we'll see the not operator. Not is very easy. Not just says you complement the bit. If there is one, it will be complemented to zero. If there is zero, then it will be complemented to one. Okay, and what we can say is that this operator is denoted by this tilde sign. This, like the one you used for destructor. Remember? So yeah, this is what not operator is. So now proceeding further, we have the XOR one. XOR operator is very easy. Like XOR operator is denoted by this, and if you want to know what XOR is, so what XOR says is that if both bits are same, like if the bits are same, then the result would be unset, and if both the bits are different, then the result would be set. So it is something like that, that if you have AB and here you have A's or B, then if you write 0 0, so both the bits are same, so answer is going to be 0. If both the bits are different, answer will be 1. If both the bits are different, answer will be 1, and if both the bits are same, answer would be 0. So this is how XOR works. Both the bits different, answer is set. Both the bits same, answer is unset. So this was the, like, easiest one, I guess. Easy things. Now let us start with a small question for you. Like I have a small question for all of you regarding the concepts we have done itself, and I hope you can answer all of them. And whenever you are dealing with the bit masking questions, remember this. You first need to think about it after writing the binary representation. First, write the binary representation for the decimal number, because it will help you like get the intuition that how I am going to solve this. Okay. So the first question is that you need to check if a number is odd or even. So you need to check whether a number is odd or even, and you don't have to use this modulo operator. So this is an interview question, that if you need to check whether a number is odd or even, and you don't have the modulo operator, then how will you solve this? So everyone in the comments, can you tell me? Okay. Devanshu, it is not and, it is single and. Okay, you are again making some mistake here. Okay, it is normal and, single and. So, if you need to check whether a number is odd or even, so what you can simply do is that write the bits something like this. Suppose you have a equals to 5. So, this is not a odd number, right? So, what you will do is that you will say, okay, I'll write something like, first I'll write the binary representation here. For 4, the binary representation is this. So after analyzing both of them, what we can say is that the bit is what? The bit is not set here, right? Like in the odd one, this bit is set, right? And in the even one, this bit is unset. You can check it for any number. For 7, we have 111. So this bit is set. For your 2, we have 010. This bit is unset. So what you need to simply do is you can simply create something like, that if we talk about one is denoted by 001, right? Something like this. There are further many bits at the back, like 32 bits. But if we are taking something like this, so we know one is represented like this. And if we do the AND of this one with suppose 5, the answer that you will get is 001. So yeah, if you perform the AND of 1 with any number, you can check out that whether number is odd or even. So if n and 1 gives you what? If the number and 1 gives you what? If it gives you 0, then it means that this bit is unset and the number is even. And if you get 1, then the number is odd. So we will write the code for it also. But before that, let us see one more question. Like let us see one more small question. So there is one small question here, which is that suppose you are given an array, like there is an array given to you, something like we have 1, 1, 2, 3, 2, 5, 5. So as you can see, there are multiple, like there are duplicates in this array. There are two numbers, 1 1, then we have 2 2, then we have 5 5, and there is one unique number in this array. So can you tell me that how we can find this unique number? Like how we can find this unique number 3 by the help of bit masking? Can you tell me? Okay, let me see here in the comments. Okay, someone said use Zor. Okay, so let us see how we can solve this. To solve this question, we all know the properties for XOR. So what XOR says that if the bits are same, then it gives you a unset result. And suppose you have something like 101 and then you again get 101, the answer that you will get is 0. So both of them got cancelled out, right? So if you have an array and if you do XOR of all the numbers, then what you will get is you will get a very simple answer, which is that you will get the unique number. Like if you say 1 1 2 3 2 5 5, so 1 and 1 is same, they'll get cancelled out. 2 and 2 same, cancelled out. 5 and 5 cancelled out. Answer that you got was 3 here, right? So first let us write the codes here, and after this we will be moving on to some more good questions, right? And we'll see everything. Like uh, after this lecture, you all will be able to solve questions regarding bit masking, right? So let us proceed with it here and start the question. So to check whether the number is odd or even, let me write it here. Public static void. Let us keep the method of void type odd even. Let us pass the number here. And after passing the number, what I need to check is that if n, and what we need to do is we need to perform the AND operation, right? If n and 1 equals to 1, then what we will say, and if it is not 1, then what we will say. So if it gets equal to 1, then it is an odd number, right? But if it does not becomes equals to 1, then it is an even number. Simple as that. So this was a very simple question for odd even. And if we need to write the code for the second one, the XOR part, let us write it also. But first, let's try to run this code. And after this, we will see many questions, right? Those who are thinking something like that, like, please give us more questions, we need to do more questions, these are the things we already know. Don't worry about that. We have many questions in the last, right? There are many questions left here, and we will cover every one of them. So don't worry at all. Okay, that is my suggestion. We are talking about all the operations also, because there are certain students there, those who don't even know what bit masking is. Okay, so the second one was to find the unique element, right? That is also a question which is asked in interview. So for that, let us keep the answer to be of int type, and here unique number, unique number, I can say unique number. And now let us pass the array here. You can write the code in any programming language, like I am using Java here, but if you want to use any other language, you can use it. Okay, like you can write the code in C++ also. Char.length, and now just take the XOR of everyone. Result equals to result XOR AR of. Okay, so this is how we did it, and at the last you will return the result. Okay, simple as that. Simply, we have done two small questions, and I guess every one of you is able to get what we have done here. Okay. Now, after this, we will do the shift questions, right? Like the shift operators, we will talk about them, and then we will start with the heavy questions. Okay, like these are the basics that we needed to cover so that everyone can take interest in this workshop, because it it doesn't make any sense that if someone is not able to understand the things. Okay, so everyone would be even then. Okay, now as we have like done two questions here, odd even unique number, I'll send the code on GitHub, right? I'll send both the codes on GitHub. Okay, two unique numbers, Raghav. We will do this question here. We will do the question in today's workshop itself. Okay, so don't worry about that. This is on my hit list now. Like you need to do for two unique numbers, we will do it. Okay, we will do the question which was asked in Amazon itself. We will do that question also. Okay, so moving on, let us talk about the shift operators, right? For the font thing, I'll increase it. Like this one, I guess, is clear to you. I guess, I hope. Okay. So for the shift operators, there are two shift operators. Okay. So shift operators are the special properties. The first one is the left shift operator, and the second one is the right shift operator. Okay. So if we just talk about them, so left shift is denoted by this, and right shift is denoted by this. So what left shift to do is that suppose you have something like this, 0010, something like this. We all know that if we convert this number into decimal form, we get 2. Okay. But now what we do is that suppose what you say that let us left shift this binary representation by 1. Okay. So what I did was I left shifted it by what? By 1, right? So if you left shift it by 1, it will become something like this: 0 1 0. So what happens is that when you left shift your binary representation, so the last bit get discarded. So this last bit got discarded. So yeah, there is, like, if you ask me, so in Java we have 32 bits in a int, right? So in, like, there are 32 bits, right? So if we start moving, so there are certain more zeros in the back here, right? So there are many zeros. So the last zero would get what? Get shifted to the left and it will get discarded. So what we can say, suppose we had the representation like this. So this zero got discarded. So it got something like this. Now what you will do is, to compensate for the discarded zero, what you will do is you will add the extra zero here. Like you will add one zero here at the back, this place. So you left shifted it by one. So you discarded like the digit which is at the left side, and then you added the zero here. Okay. So now the answer that we got here was 4. And if you do the left shift operator once again, so the answer that you will get is 1, 0, 0, a 0. So this is 8 itself. Okay. So what you can say is, whenever you are left shifting any number, right? So suppose there was 1. If you left shift it by 1, so it will get multiplied by what? It got multiplied by 2. If you again like left shifted by 1, so it will get multiplied by 2 again. So 2 got multiplied by 2 and became 4, and then we again left shifted it by 1, so the answer that you'll get was 8. Okay, so this is how things work. So a general formula, if I need to write for left shift, would be to, like, the number that you have. So the number that I had at the starting was a. Let us suppose it is denoted by a. So a into 2 raised to the power bits shifted. So if the bit shift was 1 of 1 itself, like I said, a left shift 1. So what will happen is a into 2 raised to the power 1, which is what? Which is what? 2 into 2, which is 4. If you say by 2, then it will be 2 into 2 raised to the power 2, which is 8 itself. Okay. So this is how the left shift operator works. So the working of left shift, is it clear to you? The working of left shift, is it clear to all of you? Everyone? Is it clear to you? So we will move on to the right one. Okay. Okay. It is good. Okay. Now, I told you the shift operator, Raghav. Actually, the thing was that you were asking about the unique number 2, right? So for that, we will require this shifting properties too. Okay. So we will do all of that. Don't worry about this. We will do all those questions in this workshop, and that's my guarantee. Okay. And I don't go back on my words. Okay. So left shift is clear, and right shift pretty much works the same. Okay, let me do it here. So right shift is something like that. Suppose you have 1011. Like, no, let us take the easy ones. Like, to understand things, let us make things easy. Something like this. So what will happen is that here I have written something, and if you see what is the decimal representation for this, so we can write the decimal representation very easily. This is 2 raised to the 0, this is 1, this is 2, and this is 3. So what you can say is 8. Now, what will happen is that suppose I right shift it by 1. So if I right shift this 8 by 1, the answer that you will get is something like, you will move towards this size, you will discard this bit. So 100, here was 10 again. And now what you will do is you will add a 0 at the start here. Okay. So the answer got something like this. And now the binary representation for this is 4. Okay, so what is happening here, that in the left shift the element was getting multiplied by 2, right? And here it is getting divided by 2. Okay, so this is how this shift operator works. And and for the Java people, all the students who code in Java, there are two types of right shift. One is signed right shift, and one is unsigned right shift. So this is the signed right shift. Okay, if there would have been a negative number, so we know that the sign bit for a negative number is 1 itself, right? There would be many ones in the backward. Okay, so what I need to say is, like, what I want to say is that if you consider a negative number, something like, suppose there was -5. Okay. So for -5, what we knew was that the binary represent, like, I guess the two's complement was coming something like this itself, right? And this is not just this. I told you there are 32 bits. So after these bits, there was something like 1 1 1 1 1 tit, 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 1 0 1 1. So there are certain bits which are 1 itself. And the last, the this significant bit, this bit was 1, which denoted the sign that this is a negative number. So there are many ones here. So if you right shift a negative number, then 1 will be getting added. Okay. So if I right shift this number like this, I right shift it. So I will discard this one, and I like add a 1 at the back itself. Okay. It is not at all like your that we will add a 0 here. No. In signed right shift in Java, which is denoted by this, in signed right shift, if the number is negative, 1 will get added at the end, not 0. 1 will get added at the end. And if the number is positive, then 0 will get added here. Okay. If the number was positive, hit like this, then 0 will get added for the discarded bit. Okay. And in case of negative, 1 will get added for the discarded bit. Okay. But in Java, there is one more right shift, which is the unsigned right shift, which is denoted by this triple shift operator. This, there are three greater than signs. So this is the triple shift operator, and this is used for the unsigned right shift. So what unsigned right shift says, that no matter whether the number is negative or positive, he doesn't care. He don't care whether the number is positive or negative. He will always add 0 for the bit that they will get discarded. Okay. So if I right shift a negative number and I am using this triple shift operator, so even if the number is negative, it will always add a 0. It will not consider the sign, unsigned right shift. So I hope both of them are clear to you. Uh, are you all able to get both the operator? Like if you ask me about the unsigned right shift, so what unsigned right shift did was that it shifted the bits to the right, and for the discarded bit, if the number is positive, then we will add what? Harneet is asking, unsigned is for both. No, unsigned is for only right shift. Okay, in Java, unsigned, like this triple shift operator, is only for the right shift itself. Okay, so unsigned right shift, what it do is that it doesn't like it doesn't care about the sign whether the number is positive or negative. It will always add 0. Like it will always add 0 for the discarded bit. And for the signed one, if the number is negative, then it will add 1 for the discarded bit. And if the number is positive, then it will add 0 for the discarded bit. Okay. So, okay. So everyone got, like, everyone is clear with this idea. So, okay. Now, let me give you a small question here. So, okay. Let me open this, the blocks. There is a good question here. Let me get it started. Oh, sorry. It started here. Let us see the questions. Okay, login. So, are you all able to see my password? Don't say it. Okay, come on, log me in. And then hacker blocks. Let us say app contests. Okay, 1620. Let us start with the questions. So there is one small problem that I want to give to you. Okay. So let us see. There is a small problem here for all of you. Can you tell me how we can solve this problem? Everyone. Focus on this question. I hope you are able to see the screen. Are you all able to see the question? Like, are you all able to see this question here, or do I need to increase the font size? Should I increase the font size, or it is clear to you? Like, are you all able to see the question? Let me increase the font. Okay, let me increase it a bit more. Okay, so I hope now this is visible. Okay, so now I guess this is visible to all of you. So let me say it that there is, suppose there, what the question is saying is that there is planet Earth, it is under a threat from aliens, and Marvel team is has assembled like alien or the outer, and the Marvel team is busy. Meanwhile, Hulk has to defeat an enemy who is n steps above the level where he is standing. So there is given that Hulk is there and he need to defeat an enemy who is standing n steps above the level where he is standing. Like, let us assume that it is at zeroth level. So Hulk, because of his incredible jumping ability, can take a jump of power of 2. Like, it can only make a jump which is power of 2. Okay, like he can only make jumps in power of 2, right? Only in the jumps in the power of 2. And in order to defeat the enemy as quickly as possible, he has to reach nth step in minimum moves. Like, the moves we need to minimize them. So how we can solve this question? So what the question said, like what the question said is that Hulk can only jump in the power, like in the power of 2 itself, and like he needs to reach that nth floor. So how he can reach this floor? Can you all tell me, like how we can solve this problem? So suppose the level is 5. Like, suppose the test case, let us see the test case here. So sample input, we have 3 test cases. One is 3, then we have 4, and then we have 5. So if we had 4, so the jumps that I need was 1. If there is 3, then the jumps that I need is 2. And if there is 2, then if there is 5, then the jumps that I need is 2. Okay, so these are the test cases. Like, these are the right test cases, because if you ask me 5, so what he will do is first he will take a jump of 4, and after that he will take a jump of 1, because 2 raised to the power is 2 raised to the power 0 is 1. Okay. So can anyone tell me how we can solve this question? Okay. So let us hear the questions. Like, let us see, calculate number of ones. Okay. So the first answer, let me check whether how anyone gave the answer earlier. Raghav said this can be done using Zor. Okay. And Hulk. Okay. Okay. Power. Okay. So the first answer, I guess, came from Aniswar. He said count number of 1 in the binary form. And yeah, this is exactly the correct thing. Okay. So as I have already told you, like every time you encounter a bit masking question, now the thing is that most of the students which are like present here, they might be confused that I don't even knew that we can use bit masking in that question. Like, most of you won't even recognize that this is a bit masking question. And I'll show you further many more questions which doesn't look like that we can even apply bit masking here. So bit masking you can't improve until or unless you work really hard. Like if you're working with some mathematical concept, so do remember that you can try writing the binary form for anything. Okay, so do try that whenever you are doing a question and it generally contains some numerical values and you need to work with the number itself, so at that time try to write the binary form for that number and try to think that can I apply any bit masking operator here. Okay. So what we can say is that suppose if there was n floors, like suppose the floor was 5, so let me write the binary for 5 here, and then we will count the set bits here. In the same way we have 4, let us write the binary for it, and we will count the set bit. But how we can count the set bit? Can anyone write the logic for that? Like how we can count the set bits? Okay, I hope the approach is clear to you, everyone. Everyone, the approach is clear. That what would be the answer? Everyone in the comments. Is the question clear to everyone and the answer also? Like, is the logic clear to all of you? Like, what we need to do? The what we need to do was that we just need to count the bits which are set. We need to count the set bits. Okay. So to count the set bits, let us write a method which we can say as public static int count set bits, count bits, or like you can we can say count set bits. Okay, pass the number here, and after passing the number, what we will say is that suppose the count would be 0. Now see the logic very carefully. We will say that count is 0 after checking it. Now what you need to do is, like, if you see the logic here, okay, we have something like this 1 0 1. Now, what you can do is you can see, I need to count all the ones. So, first I will do AND of this with 1. So, suppose I did AND of 5 with 1. So, the answer that you will get is 0. Like, and the answer that I'll get is I'll get a 1 here, then I'll get a 0, and I'll get a 0. So, answer I got something like this. So, what we can say is that it checked the last bit here, right? It just checked the rightmost bit, but I want to check every bit. So after checking this rightmost bit, what I will do is I will right shift my values here. Like in this, I will right shift my number by what? You can right shift your number by 1. So it will right shift your number by 1 bit, and now the answer that you will have now is 0 1 0. Now you will again perform AND. So 0 0 1. So this was an unset bit, so the answer you will get is 0. So I will not increase the count here. If you didn't increase the count is still 1, because the first thing that you performed was that first you will perform an AND operation of the number with 1. After performing that you will check that what you got 1 or 0. So here you got 1, so you will increase the count, but the answer is still not, like, this number is still not 0. Now what you will do is I'll right shift it by 1. I right shifted this number by 1, so I got something like this. So when I got something like this, I again performed AND operation. I got 0 0 0, so I won't increase the count. Now I will again right shift this 0 1 0 by 1. Okay, so the answer that I will get is, okay, so the answer that I will get here is 0 0 1. I again performed the right shift by 1. Now I will perform AND operation with 1 here. So again I got the set bit, and I will increase the count here. So the count become 2. And now if I again right shift this one by 1, so I get 0 0 and 0. And now we all know that 0 0 and 0 will always yield 0, right? So when my number becomes 0, I will stop. So in simple terms, what I can say is that I am running my loop. I'll say that until or unless my number gets 0, until or unless it is not 0, I will I will keep on what? I will keep checking that if I'm checking everything now. Okay. So if n is what? If I get n and 1 as 1, then I will say that count should be increased. Count should be increased then. But if it is not 1, then what we need to do? Like, we need to perform the right shift in every case. Even if the number was not equals to 1, I'll still right shift it, because if I don't write this here, I will never reach this statement. Okay. So what I'm basically doing is that first I'll perform AND of 1 with my number, then I will right shift my number with 1 to get the second bit. I'll check it, then I'll move to the third bit, I'll check it, and I'll keep running the process until or unless I get this. Okay. And at the last, I will return count. Okay. Now let's see whether our program is running or not. So let us say S out, and what we have here is count set bits. And students who might be thinking that which editor I am using, so I am using IntelliJ. Okay, this is a very good editor, and if you want to work with it, yeah, I'll say that this is the best editor. Even if you want to do development, this is a very good thing. Okay, so for 5 I got 2, for 4 I will get 1, obviously. Okay, so 1. So this is how we created the method for count set bits, and all the things are in the operations itself. Okay, everything. Okay, can you tell me that how many of you are able to get the solution and how many of you are not? If you are not able to get the solution, I'll repeat it. Write it down here. Are you all able to get the solution or not? If not, then I'll repeat it. If you all got it, then we will move to the second question, like the next question. Okay, got it. Okay. Vaibhav Shukla said, "Can I use this editor in Windows?" Yes, sure. Intelligence in everything, I guess. Windows, you can use in Linux. Okay. So some many students are saying repeat also. So let me repeat it like in normal terms. So everyone listen it very nicely. What we are trying to do is we need to check every bit, right? So suppose you had n equals to 5. So 5 is 101, right? We need to check every single bit. How I can check it? So what I'm trying to do is to check the last bit, to check the rightmost bit. I know I can perform AND of this thing with 1. If I perform AND of this thing with this number, I can simply check that whether this rightmost bit is set or not. So first of all, I checked it directly. Like, for if n was 5, I directly wrote the binary. Like, I got the binary for it and I performed this AND operation with 1. I got to know that whether the rightmost bit was set or not. Once I got this, now what I will do is I will right shift my n by 1, because we have checked this bit, right? Now we need to check this bit. So I right shifted by number by 1. So the answer I got was this. Now I will check it again and with 1. So you will get the answer for the rightmost bit. Now after checking it, you will again right shift, because now what I need to know is I need to check this bit, right? So again I right shifted it, so the answer that I will get is 001. And again let us perform the AND. So you checked it whether the answer becomes like the I got the set bit or not. And after this, there is no bit left, right? The answer that I'll get is 000 after right shift. So no sense checking it again and again. So once the number becomes 0, I'm ending my loop. So all of you, now you got the solution. Now you got the solution. Those who are saying repeat, those who are saying repeat, now are they able to get the solution? Like, what we are trying to do is we are trying to check every bit by moving it to the rightmost position, because we know that after performing AND with 1, we can check the last bit, like the rightmost bit, that whether it is set or not. Okay, so everyone got it now. So now, count set bit, unique number. We have done these questions. I have one more small question for all of you. Suppose I need to check whether a number is uh, a power of 2 or not? How can I check it? Like, how can I check whether a number is power of 2 or not? And I can't use any other operator. I can't use any other operator. This is also an interview question. Everyone, how can you check whether a number is uh, a power of 2 or not? How can we check whether a number is power of 2 or not? I'm waiting for your answers here. Okay. Let us see how many of you are able to get to the answer. This is a good question. And yeah, this is asked. Okay. If last bit is 0, there's not exactly like that. Right shift? No, we don't. Like, how? You are saying total number of set bits, this and that. Can I, like, pretty much make things easier for myself? Just think of it. Just write the binaries and then think. Okay. Something like, okay, let us say 4. Let us suppose we have 4. Okay. So for 4, we can say the binary is 100. For 8, the binary is 100. For 16, you know, and for 2 also, you know, 10. Right? So just think, there is a simple technique here. There is something very common here. If only one bit is set in that number. Okay, if left shift of. Okay, so Akhil has somehow got to the right answer. So the thing is that first of all, n should not be 0, and yeah, this is the constraint I am already putting, that n is not 0 at all. Okay. Now what you can do is, if you perform AND operation between n and n minus 1, this is the simplest thing. Like, if you perform AND operation between n and n minus 1, then you can check whether the number is power of 2 or not. And how? Let us see that. Suppose you were given 16, right? There is 16 that we have here. Or let us suppose, let us take the answer for 4 first. So we have 100, and if you say what is 3, what is the binary for 3, we all know 011. So all these bits are set. Like, every time we all know that when we reach something like in the power of 2, then the most this bit is set and every other bit before them would be 0. And if you just take the number before it, like this was 4, and if you take the number just before it, every bit would be set here in the rightmost direction. Just that bit will not be set, which will make the answer to be 4. So if I perform AND operation between this 4 and 3, what I will get is 10, I got 0, 01, I got 0, 01, I got 0. So what you can simply say is that if you need to check whether a number is a power of 2 or not, you can simply ask, see this, like n and n minus 1. If it comes to 0, then your answer is correct. It is a power of 2. So this is a very good hack which you should remember. Okay. So I hope it got you stunned, because when I was doing bit masking, it did got me stunned, because I had no idea that there is some powerful things like that. Like, this is something I could not imagine of. I was just the same like you, shifting the bits and I'll get the answer. And then I was like, wow, my whole life was a lie. Like, programming always gives you some concepts which makes you think that whether you are living a great life or not. There are many things like that. Okay. So yeah, the pain of programmers. Okay. Every time we get something new, and then we are like, oh, that was like, okay. So I hope you all got this. So if you need to check whether a number is power of 2 or not, you can simply use this approach. Simple approach, simple, sober, easiest. And I will give you one more big brain. Yeah, like this Anup, this big brain. I guess you are a fan of PewDiePie, I guess. Okay. I guess you're a fan of PewDiePie because PewDiePie uses this word big brain. Okay. I don't know whether you watch him or not. Okay. So now there are some Raghav Sharma. Okay. There are two questions that we are doing now. First question would be the question which was asked in Amazon, and it is a very important question. After that, Raghav, we will go according to your demand, unique number two. Definitely, man. We will do this in this lecture itself. Don't worry. Don't worry. I'll make it work for you. Okay. So let's first do the question that was asked in Amazon. So I guess I have got it here somewhere. Let me check. I have added the question, I guess. Bit masking. Bit masking. Okay. Let us see where the question moved to. Okay. So I got the question here. Please see this question, everyone. This is a very simple question. A magic number is defined as a number which can be expressed as a power of 5 or sum of unique powers of 5. So this was the question which was asked in the Amazon interview for software developer, right? This is a very simple question if you think about it, but yeah, those who don't know bit masking, they might get confused in this. So a magic number is something which is defined as a number which can be expressed as a power of 5 or sum of unique powers of 5. Like they're talking about unique powers of 5. Yeah. So first few magic numbers they have already told you they are something like 5, 25, 30, 125, 130. So how you are getting these magic numbers? First you will get 5, then you will get 25. After that, you can get the third number by adding them 5 plus 25, which is 30. Then you will get 125. Then you can add 5 in it to get 130. After that, you can add 125 plus 5, something like that. Okay. So, this is how things are working here. Okay. So, this is how you need to solve this question. So, what they're basically saying you is that you need to find the nth magic number, and these are the first few magic numbers 5, 25, 30, 125, 130. So how can I solve this problem? Anyone in the comments, how can I solve this problem? Anyone? Vignesh here is saying in the way finding a unique number input must be sorted. No. It doesn't matter that whether the number is sorted or not. It doesn't have to be in a sorted sequence. It will just do the complete XOR, right? So obviously the numbers which are same will get cancelled out. So doesn't matter. Okay. Okay, so I am waiting for your answers. Like this is the question. I have already explained it. There are like certain you need to find the magical number, nth magic number, and you are given first few magic numbers which are 5, 25, 30, 125, 130. How can I solve this question? Okay, let us see. Devanshu is saying treating each bit. Devanshu, can you be a bit elaborate? Like, can you elaborate your answer? Okay, so Minakshi got some answer here. While n naught power equals to power into 5, but this is not the complete solution, Minakshi. There is something left here. Everyone, do try it on your own. Like this is a very good question, and Amazon asks good question, and when you get to know the answer for this you will be stunned. Like this is the simplest question, I guess. Like, I don't know, but yeah, this is a very good question. Okay. So, okay, please explain the question again. Rishu said. Okay, so what we need to do is that suppose you are given let us see, suppose you need to find the nth magic number, and the magic number is defined as a number which can be expressed as a power of 5, like it could be a power of 5, and it can also be the sum of unique powers of 5. Okay, let us see the unique power. It cannot be 25 plus 25, something like that. No, unique powers. Okay, so first we got 5, then we got 25. After that we can add these because they both are unique, so 5 plus 25. Then we got 125, and then we got 130, then we will get 150, something like that. So how we can solve this? Okay, so Minakshi had given me the answer here, I guess. Okay, okay. If and okay, okay. Yeah, exactly. Something like that. Devanshu, okay, 0 into 20. Yeah, exactly, Devanshu. You are also correct. So, those who were not able to get the answer and those who got the answer, great. So, both of them, let's now see the solution for this. So, this is a very simple question. Like, if you ask me, what you need to do is like every time I say that whenever there is a numbered form question, you will always write the decimal representation for it first. Every time whenever you need to deal with numbers, there might be a chance that we need to apply bit masking operations here. If I wouldn't have told you, you would have never known that I need to apply bit masking here. No one knows that bit masking is a very tough thing, which kind of haunts everyone, that when we should apply this approach. So this is basically when you are dealing with the mathematical stuff. Okay, so what you can say is that suppose there was 0, 0, 1. Okay, so this is 1, like the like the binary representation for 1. So if now I write what, if I see that here this bit is set, and if I multiply it by 5, I get 5. In the same way, if there was 2, let us write the binary representation for 2 here, 0, 1, 0. So this is 5 into 0, this is 5 into 5, and this is, like, what you know is that here I can't take any other power of 5, right? Because 5 into 3, like 5 raised to the power 3 into 0 is 0 itself. Okay, so what you are doing is that you will check the set bit. Like if the bit is set, then okay, you will consider it and you will add them. Okay, so suppose you have 5 and we have 101, right? So here what we can say is we have 5 here. For 5 raised to the power 2, which is 25, I won't have that because this is 0. But if I come here, we have 125. And if we can say 125 and 5, both the bits are set. So I'll add both of them. Okay. So what you are simply doing is that you will take the number, you will just like the process is same, like in the set count bits, right? We will move until or unless the number becomes 0. We will check every bit that whether it is 1 or 0, and we'll keep on increasing the power itself. Okay, so let me write the solution for you. Okay, let me write the solution for you and you will understand everything here, right? So let us say public static int. Okay, let us name it magic number. This is a better question than you like. This is a good question which is generally asked, and there's an asked question in Amazon. It is not something like that I'm bluffing. It is definitely like even you can see that test. Like I don't know if it is available online or not, but the student who gave this test, this was the first question, and this was of, I guess, how much points, I don't remember the points, but it contained good weightage. Okay, so here, let us write the n. After writing n, what you will need to do is that first of all, you need certain things, right? Certain things. So we know that if the like when we are starting with 5 itself. I'm not starting with 0, I'm not starting with 4 5 anything like that. Let me check in the comments if someone is saying anything. Okay, so there is nothing, no one is asking anything right now. So okay, what you first do is that whenever we are multiplying, we generally keep it 1, because multiplying anything with 0 is 0 itself, right? So we'll keep the power to be 0. And after this, what we need to do is we need an answer also, the answer that we will be returning. Okay. Now what I will do is I'll run a while loop, and in the while loop I'll say that until or unless my number becomes 0, I will keep on checking the bits, like the same process as in the set bit count one. But here, what I will do is first I will multiply my power by 5. Okay, so now if the first bit is set, then I will add this 5 into my answer. Okay, so I will check that if your n and 1 is equals to what? 1. If it is equals to 1, then answer would be equals to answer plus power. And I will, after this, what I will do is I will right shift my number by 1, like the same thing we did in the set bit count one, right? And at the last, we will return our answer, that what our answer is. And now let us check whether the answer that we are getting is correct or not. So magic number for 5 was 130, I guess. So let us check it. Okay, so the answer that you are getting is 130, which is correct. And this is how this works. Okay. Okay, so got it. So most of the students got the answer. And this was a very interesting approach. Okay. So let me check. Is everything clear to you now? Okay, let me check it here. Not able to see your comments here. Okay, YouTube CB cb.lk slash. I'm not able to see your comments. Let me check it out. Is there any issue here? Okay, so no issues. Let us start with the next things, right? Okay, so show the code, please. Okay, I'll show you the code, and the second thing is that I will push the code in on GitHub, right? I'll just create a GitHub gist and comment it below here, like in the section, comment section itself. Okay, so let me create. I'll create the GitHub gist and send it to all of you. Okay, like I'll comment it in this. Okay, please show the code. Okay, let me show the code to you. So the code was pretty simple. First, you took one power variable, you set it by 1, because whenever we are working with multiplication, we like set it with 1 itself. Okay, because multiplying anything with 0 is 0. Okay, then we took the answer in which the answer we will store. After this, what we did was that until or unless my number becomes 0, I'll keep on checking the rightmost bit, and if the rightmost bit is set, I will add that power into the answer. So if I had 101, so first of all, power got multiplied by 5, so 1 into 5 is 5. Then I checked whether the rightmost bit is set, so yes. In 101, the rightmost bit is set, so I will add this 5 into pow, like this in this answer. Okay, then I right shifted it by 1, and I will move to the next bit, and in the same way the process goes on. Okay. Okay, so now let us move to the next question. And this question is very interesting, and this is the asked question by Raghav, and Raghav really wants to know the answer for this. Okay, so Raghav, let us proceed with your question. Sorry to make you boy wait, but yeah, this is a good question, and let me write a heading for it also. Okay, unique number 2. Number two, asked by Raghav. Okay, so this is a question which is asked by Raghav, like he was waiting for this, like when will sir answer this? Okay, view. Okay, paper style, let's change it. So unique number two, asked by Raghav. Let us answer this. So this question is that suppose you are given an array and it is something like 1 1, then we have 2 2, then we have 3 3, suppose something like this, okay, or let us suppose, let's keep it 7 itself, okay. So you are given certain data like this. You have these duplicates here, but in this we have two unique elements. So what unique at number two question says that it says that you are given an array in which there are duplicates, but there are two numbers which are unique. So 5 and 7, they are unique. They are not repeating. Okay. So how can I find these two numbers? Now the thing is that many of your students are stuck in this, right? Okay. Okay. Amit is saying that sir please Hindi mein samjhao. Okay, Amit, don't worry. I'll explain it to you in Hindi also. Okay, first I'll give the English version, then I'll get the Hindi dubbed version. Okay, don't worry about that. We'll do it in both the languages. Okay, so first of all, I am telling the answer in the English one, and after that, I will move to the Hindi one. Okay, let's start. Okay, so many students are saying that by the help of Zor, okay. So, okay, no problems. Let's see the question and we will get everything. Everything. Now, proceed with everything step by step. Use hash map. No, we don't need to use any extra hash map or something like that. I don't want to use extra space, okay? Like a linear space is bad. So, let us see. Suppose the array was something like that, right? 1 1 3 3, then I had 5, then I had 7, something like this, okay. Or let us change the element so I get something like this also. Okay, now this looks good. Now what I need to do is that suppose we are given this array. So what you will do is that we all know that when we do the complete XOR, when there was the unique number one question, so in that we got the unique element, right? But here we all know that there is no unique number here, right? Like there are two unique numbers, but there is nothing like that. If we do the complete XOR, we'll get the answer and everything would be easy. So there is nothing like that. Okay, so now what should I do? And if I make this array pretty, like let us say that I make things easier for you, like by the help of this you might not be able to get the solution. So let us make it that you get every step very nicely. So I changed the data here a bit. Okay, I'll tell you why I changed it. So first of all, first step, first step is just the same as unique number one. You will take the XOR of all the elements. Just take the XOR of all the elements. So this cuts out, this cancels out, like, and now you are given 5 and 6. So what happens is that when you take the complete XOR of the array, you will get something like this got cancelled, this got cancelled, but you are now left with the XOR of 5 and 6. So let us do the XOR for 5 and 6. So can you tell me what is the binary for 5? So the binary for 5 is 101, right? Something like this. Okay. Now what is the binary for 6? It is something like 110, something like this, I guess. Right? Everyone? Is this like this much part? I guess everyone will get that. So we did, like, now we are doing XOR here. So let us do the XOR. 10 we get 0, 01 we get 0, and oh sorry, my mistake. Wait. It is stuck. Wait, I made a mistake here. I wrote 0 there, right, instead of 1. My mistake. So what I do is that you will write your 101, then we will have 110, and when we take the XOR of it, we get 011, something like this. So what XOR said to us was that whenever you do something like this, if the bits are different, then the answer that you will get are the set bits, and if the numbers are same, the answer that you get is 0. So I performed XOR of all the numbers, and this is what I got. XOR for this, I got 1. XOR for this, I got 1. And XOR for this, I got 0. So I am left with something like 011. Okay, now this is fine. This is something I have now. I have this mask. You can say that this is my result, which I have after performing the XOR operation for all of this. Okay. So now, what should I do? What is the use of this? What can I do with the help of this result? Let us say this is a result of this, like XOR of this. So after thinking a bit, like after seeing at it, what I can say is like there is one thing I can pretty much say, that the thing, like if one is coming here, then any of the two, like it is not possible that both of them contains this one. Any of the two contains set bit at the rightmost position. So the meaning, like if you take the complete XOR of the array, and now you have got the XOR of these two, like these two were the unique elements, right? So the XOR you got was 011. So it means that if there is a set bit here, so it is definitely true that there must be any number, either like there must be any number in both of these unique number which contains this set bit. Like for example, if you say 101, so in this result, this rightmost bit is set, and in this 5, like the binary of 5, this rightmost bit is set. So there must be a set bit. That, like, this is a complete deduction. It is not something like we are guessing or something. It is something which is true, that if you take XOR of two numbers, then you are only able to get one if any of the two contains one and the other doesn't contain that one. Okay, so both, like you can't say that in 5 also this bit can be set, and in this 6 also this bit can be set. You can't say that, because if both the bits are same, then you would have gotten a 0. But if you are getting a 1, so either one of them contains this position bit to be set. Okay, now once we got to know that yeah, this fact is true, now I will try to solve my question. Okay, so now I will try to solve this question pretty easily. So by deducing this, I know that there must be any out of these two in which this rightmost bit must be set, and we know in 5 the rightmost bit of 1 is set. Okay, so what you need to do is now you need to create a mask. There is something called mask. Okay, by this mask I am able to solve my question. Okay, this mask will help me solve my question, and let us see how it will help me. Okay, so suppose now in this result, in the result, to create a mask, what you do is you will check that what is the first set bit that I encounter in this result. You need to find the first set bit in this result. So the first set bit is here itself. Here it is directly coming to you. So in every time you are solving this unique number two question, first of all, you will take the XOR of the complete array. Once you take the XOR of complete array, you will get a result. And in this result, you need to find the first rightmost set bit. So the first rightmost set bit is this one. Okay. If the result would have been something like 010, so the first set bit, like the first rightmost set would have been this. Okay. So once you get the position for the first rightmost set bit, you will take a number one, like you will take this number one, like this is a number which we are taking one. Okay, So you will take 1 and you will right shift it, like you will, wait, sorry, left shift it. Okay, wait, let me check where the problem is coming. Like this OneNote is not working nicely here. Okay, so yeah, now it is working pretty like nicely, because all of that was going away. I don't know why it was working like that. So okay, once you get to know that where is the bit, like suppose in this, like if the result would have been something like 0 1 0, we all know this, right? So if the number would have been 0 1 0, so here the first rightmost bit is here, so the mask for this would have been 0 1 0 itself. If the number would have been 1 1 0, so the mask for this, like for 1 1 0, first of all we will find the first rightmost set bit. So the first rightmost set bit is still at this position, okay, the second position. So what I will simply say is that if it is at this position, then no issues. We will simply do what? We will take one and we will left shift it by what? You will left shift it by the count, where, like you will left shift it by the position where you got it, right? So suppose, let us suppose that this position is 0, like we are moving according to the indexing, right? Like according to the indexes. Suppose this is at the 0th position and this is at the first position. So what I can say is that if my rightmost bit is present at this position, at this first index, so if it is present at the first index, then I will shift it by 1 itself. Okay. And if it is present at what? Suppose it would have been present like this, like in this, the first set rightmost bit was at this position. So I can simply say, okay, I will simply say that the mask for this would be 1 left shift by 0. Okay. 1 left shift by 0, I get 0 0 1. So this is how I will be creating my mask. So let us go through all the steps again, and let me put my laptop on charge because it is discharging here. Okay, so I have put in my laptop on charger again, and now let us proceed. Okay, so here what we were doing was, see, I know every one of you is confused right now. Like most of you might be confused. Let me repeat it once again, and I'll repeat it in very simple terms. Okay, first of all, take the XOR of all the elements. So once you take XOR of all the elements, you will get the XOR. Like once you take XOR of all these elements will get cancelled out because they are just the same. And we know once we do XOR of same elements, we get 0. So these got cancelled out. And at the last, the result that you will get will be the XOR of these two unique elements. You will get the XOR of these two unique elements. So once you get the XOR of these two unique elements, after getting the XOR of both of them, you will check in this result the rightmost set bit. So for after getting the XOR of the whole array, the result you get, you will check the rightmost set bit in that. So the rightmost set bit in this is placed at the 0th position. So once you get to know, okay, this was placed here itself, or we can say that suppose the position, if you are not moving according to the indexing, then I will say that suppose we got 1 at the first position itself. I'm denoting it as position now. I'm not talking about the indexing. So suppose I got the set bit at the first position itself. So I will say that now I have to create my mask. So to create my mask, I will left shift this 1 by what? The position where I found, like the position where I found the element -1. Okay, because if you say this is the first position, so you will shift it by position -1. 1 minus 1 is 0. Okay, or you can say that if you simply got it at the first position, you don't have to left shift your number at all. You don't have to left shift 1 at all. So simply you can say that it is 0. If you found the rightmost set bit at this position, then you will say, okay, I will shift it by 1 because I got it here. Okay. So now if this much part is clear to you, let us first write the code till here. Okay. Let us first write our code till here. Okay. Okay. So some students. So sir, find many. So if the array would be, then will there be a unique element? इसमें okay, okay, okay. So Raghav, is the solution clear to you now? Like the steps we are proceeding with. Wait, let me write the solution here itself. Public static int. Okay. Unique number two. Let us name it unique number two. Two. Let us pass our int n here. And now move according to the step. First step was we need to take XOR of our complete array. So the array we will pass it here. Then we will take the complete XOR. I need to take the complete XOR of the array. For loop I will take. Like every time, like I suggest to everyone that whenever you are solving a question, just do it in steps. It helps a lot. So first of all, I said, okay, I'll take the sit the things here. I'll take the XOR of every element, and yes, I got the XOR of every element here. Once I got the XOR of every element, like the whole array, now I need to find the rightmost set bit. Rightmost set bit. Okay. Now, and it need to be the first rightmost set bit. Okay, you should not check every set bit. Once you get the first rightmost set bit, you will break the loop. So for that, what I can say is that let us suppose we took a temporary variable and stored our result here, and then what I am saying is that while my temp doesn't become 0, while temp is not equals to 0. Okay, now I need a count also, because I need to count by how many times I need to shift my one, right? Like I was trying to create a mask, right? So for that, I need to know exactly how much shifts I want to do in one to get my result. So first of all, I took the took the XOR of all elements. Now I am checking out the first rightmost set bit. So if like this is a simple process that if temp temp should be what? If temp and one, like you are doing and with one, gives you what? Gives you a one. So yes, it means that you encountered a set bit. So once you encountered the set bit, you will simply say break. And if you didn't encounter the set bit, then you will say, okay, I will shift it. That how many times? Now I will shift it. And if you are shifting your bits, so obviously what you need to do, you need to left shift it, row, right shift it. Okay. So count equals to count plus one, and then I will say n equals to, oh sorry, temp equals to temp right shift one. So this is a simple process. This is to check. Like let me write a comment here. This is to check the first rightmost set bit. I'm taking the first rightmost set bit. Okay. This whole process is to check the first rightmost set bit. Now, once I check this set bit, once I get this set bit, now what I need to do is that I need to create my mask, the mask I wanted. So, okay, this mask can be created how? We can simply say one right shifted by the count, right? Because suppose we had 0 1 1 in the result, so the first rightmost bit would be where? At the first position itself. So you didn't had to left shift your one by anything. It should be like this itself. But if your result would have been like this, suppose your result would have been like suppose 0 1 0, like this, 0 1 0. So here like 1 1 0, let us suppose. So here I found the set bit. So I will say that my mask should get left shifted by 1, because you didn't find the set bit here. You got the set bit after shifting it by 1. Okay. So once you right shift it by 1, in the same way you need to shift your left shift your mask by 1. So for that, I am using simple technique here. I checked the rightmost bit and I created a mask. I left shifted by the count that I got. Okay. Once I got everything like this, like, is this much part clear to all of you? Can you all tell me, please? This much part. This much part is clear to you? Like the process we have discussed up till now. Okay, it is clear. This is left shift. This mask one is left shift. Okay, everyone. This mask one is left shift, and this one is the right shift. Because here you need to check the rightmost set bit. Okay. Okay. So everyone, I guess the process is clear to everyone. Okay. So now let us proceed. Okay. Once you have done the process up till here, now it is a very simple thing. Now the mask, like let us say the mask for our answer was what? The mask for our problem came out to be something like this: 0, 0, 1. For this, the mask is this: 0, 0, 1. So now everything got simple for us, because now we don't need to do anything. We just need to do what? You just need to check, like the numbers were like this, right? 2, 2, 3, 3, and 5, 6. So now what you will see is that, let us say, what are the binaries for this? For 2, the binary is 0, 1, 0. For this, 0, 1, 0. For this, 0, 1, 1. For this, 0, 1, 1. For 5, we have 1, 0, 1. And for 6, we have what? For 6, we have 1, 1, 0. Right? So now our mask was 0, 0, 1. Right? So we will check in how many numbers, like in how many numbers this bit is set. So if we take 3, so 0, 1, 1, let us perform AND between 3 and our mask. We will perform AND between our 3 and mask. So the mask was 0, 0, 1, and your uh, number was 3, right? So if you perform AND operation here, so the answer that you will get, so can you tell me what is the answer here? So 1 is 1, 1 and 1 are the same. Okay, so we will get a set bit here. 1 and 0 are different, 0, and here also 0. And if it would have been 2, 0, 1, 0, mask, do AND with mask. Okay, do the AND with mask, 0, 0, 1. Okay, let us see the answer. It is 0. Okay, so according to the mask, only the numbers which contains this bit as set will yield you an answer greater than or equals to 1. Okay, if your number contains what? Contains 1, then they will always yield you an answer greater than 1. Okay, always remember this: greater than or equals to 1. So what I need to say is that if you perform AND between ARI and mask, what you will get is that if you get the answer to be greater or equals to 1, then they are of same group. So for example, I am trying to make two partitions. The one which contains this bit as set, so 3, 3 and 5 will come together, and 2 will not come here, 2 will not come here, 6 will not come here, because these bits are not same. So if you perform XOR of these three, you will get 5. And once you got 5, you can do the XOR of 5 with your result and you will get the 6. Simple as that. Okay. Once again, let me repeat it. What you need to do is you will traverse your whole array, and after that you will check that which of the numbers contains this mask bit to be set. And to check that, what you will say is that I will perform AND between my mask and my array element, and if the number comes out to be greater or equals to 1, So this number contains the mask bit as the set bit. So I will simply say, like here, I will simply say that let us suppose x equals to 0. I will run a for loop from 0 to what? From 0 to the array length. And after that, I will say that if AR of I and mask, if I perform the mask like the AND operation between AR of array element of I and mask, then it should be greater than equals to 1. If it is greater than or equals to 1, I will say result equals to result XOR what? AR of I. And once I did this, I will sorry, result, oops, I wrote result here, it should have been x. Okay, so what I will say is that now I have got my result as this, like the 5 is now stored in 5, like in x. So if I want to retrieve the second unique element, so for that you don't have to do any work, you just have to write one thing, which is suppose you take one element as y and just write x XOR your result. The result you got after doing the XOR of your whole array. Okay. And at the end, you will simply, like, let us suppose, let us print, okay, we are returning something, right? So instead of returning something, let me make it void itself here. Let me make it void itself. And let us print your x and your y. Okay, let us try to run the solution here. S out unique number 2 and array, let me suppose change it, let us change it a bit and let us say AR. Okay, and let us remove this S out because now our method is of void type. Try to run it. And yeah, we got 5 and 6, which are not the same. Okay, and if we keep 5 here, doesn't matter, it will still return me 5 and 6 itself. Okay, so I got 5 and 6, and this is how you will perform the question, like you will solve your question for unique elements, right? And you can test it out for any elements and it will work the same. Okay, so I got 7 and 5, so working perfectly fine. So please go through this approach once. Let just see the code first. Okay, till then I'll put my phone on the charger. Okay, so meanwhile take a look of the code here. Okay, let us keep it on charge. Okay, so I hope this process is now clear to you. Please, everyone, I'll share the certificate link here very soon. Okay, I'll share the certificate link here. Don't worry about that. I'm sorry that if you are not, if I have still not sent the certificate link, I have told my TA they will send the certificate link here. Okay. And the second thing is that first tell me, are you all able to get this solution? Are you all able to get the solution that I told you? This one, unique number 2. Raghav, are you able to get the solution? Ikansh, it won't work if there are three numbers. No. For three unique numbers, there is a different approach. And yes, you can do it with bit masking. No issues. Easy approach. Okay. So Raghav को भी clear हो गया. Yeah. So Raghav, I told you your answer. I guess you are satisfied now. Like this was the most awaited question for you. uh, I'll just give you a small recap for the steps that we did. First of all, we took one result. We took the XOR of all elements. Once you take XOR of all the elements, the answer that you will get is the XOR of the unique elements. So suppose the array would have been same 2, 2, 3, 3, and 5, 6. So the result would contain the XOR of 5 and 6. And the result that you will get, now you will check the first rightmost set bit. And to check the first rightmost set bit, you made this uh, process, right? To check the first rightmost set bit. So once you check the first rightmost set bit, you are incrementing the count, that how many times I shifted my number, right? Like suppose the result was 011. So we didn't had to shift our number at all. So the count would be zero. And the count, like this count is what? This is helping you create your mask. This mask will get created how? It will be according to the first rightmost set bit. So if your first rightmost bit would have been the first bit, like 011, so we got 1 at the first position, right? So the mask is 1 left shift position minus 1. So position was 1, 1 minus 1 is 0, and you got your mask 001. Okay. If the result would have been 110, so your mask would have been 010 for that, because the rightmost set bit was at the second position. So 1 left shift position minus 1, which is your 010. Okay, so that is how we created our mask. And once we created our mask, now we will check that in which numbers this mask bit is set. Like for example, our mask is 001. So we will check in which numbers this rightmost bit is set. So in 3, it is 011, right? So the rightmost bit is set just like the mask. So yeah, we will take it in our XOR. 3 again, we will take it in our XOR. 5, we will take it in our XOR. But if it comes to be 2, then we won't take it. So for that, we created this logic, because if you take 001 and then you do and of it by any other like any number which doesn't contain that set bit, then it will return 0. Okay, but if it contains that set bit, so it can give a result greater than or equals to 1. So I am only taking the results into consideration for which the XOR comes out to be what? Greater than or equals to, like this and comes out to be greater than or equals to 1. So I am taking the XOR of only those elements. Okay, so this was the process for that. And once I got my single answer, like suppose you got one unique element 5, so you can simply take a XOR of that finded unique element with the result one, right? So if you take XOR of x and the result, you will get the second unique element. Okay, so this is how this question was solved. So I hope this is clear to you. And yeah, uh, certificate link, I guess we have sent it. Haven't you got the certificate link yet? Haven't you got the certificate link yet? Let me share it then, if you haven't. Okay, let me share it here. Okay, let me check what the link was. Okay, wait, let me check what the certificate link was, right? I don't remember that. Okay, HTTPS, HTTP. Uh, okay, so it is something like this. Everyone, the certificate link is something like this: cb.lk slash bit slash 30. Okay, everyone, check it out. Is this link working? cb.lk slash bit slash 30. Okay, so by the help of this, you can, I have written here. Okay, by the help of this, you can check it out. Like if you want the certificates. Okay. And now there is one last, I guess there is one last question that I wanted to, not working. Wait, let me check it out. I guess it should work. cb.lk slash bit slash 30. It is working fine. It is working fine. It is working fine. Yeah. I was able to do it nicely. Okay. Let me let me share the complete link here. I guess this will work itself. Okay. I sent you the link for the form itself. Okay. Okay, so working, everyone. Cool. There is one thing that I want to tell all of you. Please, just listen to this. This is the last thing that I want to tell you. That if you want to, like, I didn't told you about swapping two numbers, right? Using bit masking. Like, if you don't have to use any temporary variable and you need to swap two numbers without a temporary variable. So this is a very simple approach. What you will do is that suppose A is 5 and B is 6. Let us suppose. So what you will do is, first of all, you will take XOR between A and B. So XOR of A and B, we all know what does it give? 0 1 1, right? Because these are set bits and this is the unset one. Now what I will do is that I will store B equals to A XOR B. So this was stored in A, right? This 0 1 1 was stored in A. And if I do XOR of this 0 1 1 with what? B was what? B was 6. So 1 1 0. If I do the XOR of this with the A1, the answer that I get is 1 1 1 0 1. So 5 got inserted in B. And if you want 6 in A, so again you will write A's or B. Okay. So B contained 1 0 1 and A contained that 0 1 1. So if you do the XOR, A will get 6. Okay. So this is how you can swap two numbers without using any other temporary variable. This is also a good hack which you can use. So I just wanted to tell you this. Okay. Sorry I told it at the last, but it is a good approach. Okay. So do use it whenever you want. Okay. Okay, so my name, acha, I didn't give you my introduction. Okay, so sorry for that. So my name is Shubham, and I am a Java instructor at Coding Blocks, and I hope we meet soon. And I have also worked with products regarding Red Hat, like the projects that they have, like Debezium and Quarkus. There are many projects under Red Hat, so I have also worked on them. And yeah, I contribute a lot in open source. Okay. So I guess every like okay, I guess like we have done so many questions today in our workshop, and we have also done many things, right? We have already done a lot of things. Okay. So now let's end our webinar because it's already late. Like we are already late now, and I hope that you got to know many good things after this webinar, and you got to understand many concepts like how things work, everything. So I hope everyone of you is clear with all the concepts that we did in bit masking, and you all are able to now you all will be able to solve questions regarding bit masking. I'm pretty much sure because we did everything from scratch. We saw most hacks, we saw every basic thing, and we also did questions itself. Okay. So we'll keep on doing sessions like this and everything. Okay. So let me share the GitHub link here. Don't worry about that. Let me copy the whole code here and create GitHub just oh ghosts. I wrote ghosts and ghost. Oh god. Just let me see that have I already created some gist or not. Okay, so I have created some gist here. Okay, just description, let us say workshop, and file name, let us say bitmask. Okay, let me paste the code here, complete code. Create, oh shit, I created a secret gist, sorry. Let me create one public gist. So let me create a public gist here. So I have created it. Okay. And let us share it. Okay. So this is the gist for the for today's lecture. Please tell me that whether you all are able to access this or not. I don't know whether it is public. I guess it is public. Everyone, are you able to access the gist? Everyone, are you able to access the gist that I just sent here? This gist GitHub. I guess everyone is able to see that. If not, tell me. I'll just create one more. Okay. Okay. So I guess everyone is able to see the code here. So yeah, let us wrap up our session now, and we will keep on doing such workshops, and we will keep on like doing things in Java itself. Like competitive programming can be done in Java, and we will do everything, right? So for today, let's end it up. And thank you for staying with me. So let's meet you some other day. Okay. So thank you and stay safe. And again, happy Independence Day to everyone. Okay. So thank you and goodbye.